Hi there, I wanted to give a quick tutorial on the Max Content Graph, or MCG. What we're going to do is take a piece of geometry and put a modifier on it that will clone that geometry between 2 points, interpreting the distance. You can add any number of clones, and as you drag this around you'll see that it is creating those things and updating them live. So we can delete this and show you how we built it. You'll see this new scripting panel. You can pop open this window here, and really this is a little node-based editor where you can build modifiers or all kinds of cool stuff. People compare it to ICE. It's not ICE, but it potentially could do a lot of the same things and more down the line, but this is the first release and you can already do some really cool stuff with it. So to start off, I'm going to build a little cloning modifier that will take a teapot and will put clones between 2 points. So we'll start off by making a teapot here in the center. That guy going there and a couple of points. So the idea is that I want to put a modifier on this teapot. It's going to clone teapots in between these 2 points, control the amount of points. If you move these points around, it'll always keep the same amount. So it's going to interpolate the distance here, and it's going to place these teapots accordingly. So once you've launched the Max Content Creation Graph here, you can do New, and here we go. You've got all these operator nodes up here. It can look kind of daunting, but there's some cool features where you can search for different things. We know right off the bat we're going to need an output, and there's some different output types. Output modifier, since we're making a modifier, and we're going to need an input too. Let's do modifier. That's probably still in there. So modifier try mesh. So what this is going to do is it's going to bring the information of this teapot here. When I put the modifier on there, it's going to pipe in information about the teapot, and then it's going to dump it out into the stack and affect that teapot just like a regular modifier will. So really what we want to do is we want to get positions for these 2 points, and we want to do a linear interpolation between them. So let's start off by setting up those nodes. There's a node called parameter. You'll see the different parameters here. I want a parameter inode. That allows me to select within the scene another object, so being these nodes. So we'll call these point 1. If I shift drag this guy, I can duplicate it. You got a point 2. And now this is dumping out a node here. We also can do a validation check on these nodes, which is to say only run this thing if these nodes, if you've selected these 2 nodes within the modifier. So let's see if we can search this here. Check node validity, that's what we want. Shift drag that, grab another one of those. And then from there, we want to take this node, which holds information about whatever's selected, and we want to dump out its position. So we could do node position here. I've got this little asterisk up here, which is like a wildcard search. It searches for everything. So if it didn't start with, if I just wanted to type in position, I'm going to get everything that starts with position. Put the asterisk first. And I got node position here. So let's drag one of those guys out. These different colors you see on the ins and outs of these are different data types. So node's green, vector here, so that's the position of one node, and that's got that orange color there. So now we've got these 2 vectors, and we want to interpolate between them, figure out points between. So there is a array of lerp vectors under geometry. This is going to take these 2 positions, these 2 vectors, and account a number of them, and then it will place them between. So just like we had a parameter and a parameter to bring in the 2 nodes, and a parameter to bring in the mesh that is the modifier, we'll build another parameter for account. So these will show up in the UI, and you'll be able to indicate how many of these teapots you want instance in between there. So let's do parameter again. So we have these different data types here. inode. This we are going to want an integer 32, so that's going to be a whole number. That way, since we're talking about a number of clones, we don't want 0.5 clones. We're just going to want a whole number. You can set a min-max. Let's say clones. This is how this will show up in the UI. Min-max is 100. Let's do default 3. Okay, so now that we've got these two vectors and a count, this is dumping out an array. This will be, in this case, if we do the default 3, there's going to be 3 items in the array, 1, 2, and 3, and there'll be 3 different vectors that'll be the interpolated distances between our 2 points here. So what we want to do with that is we want to combine that with the mesh. So the mesh basically instance the mesh on each one of those positions that this thing is kicking out. So we'll do we already have P up here. So something called a parallel combine. That is going to combine our mesh with the positions. But before we can just dump the mesh in, it's not quite the right data type. We need to make an array of meshes too. So we've got, as a default 3 positions, we need to build 3 meshes. We can throw in a array of. What this guy is saying is, hey, I'm going to make an array of this mesh, and it's saying, hey, integer, how many times? Quick tip, there's a little information down about these nodes here. Creates an array that copies the given value n times. So copy this mesh n times. We'll use the same value we used for the number of clones here. So this node is making a number of positions. These nodes are making a number of meshes, and we'll wire that mesh in here. And then there's a function here that says, hey, I've got a bunch of meshes, I've got a bunch of positions. What's the relationship? So there's a offset mesh, or offset meshes, I don't know if that matters, and we'll wire the function in here. So it's basically going to offset these meshes into these positions. And then you see again, I can't quite dump that array straight into the tri-mesh. I need one more node in between there. So there is another node called combine all meshes. Another way you can do it here is if I just drag this one out, it's going to bring up a list of only the compatible nodes that I can hook up. Now some of these are the any data type, so there's a bunch, but it's searchable as well, so I can do that asterisk combine all meshes. That's what I want. So that is going to turn that array of meshes into just a single mesh, and then I'm going to dump it out here. So now that we've got this flow here, we just need to save it and evaluate it, and it will show up in the modifier list as a modifier. So let's do a save as, clone lerp on position. Save that. Under build, evaluate. There's a little information down here at the end. Save, validate, success. Okay. We'll close this for a moment and let's apply this thing. So we've got our teapot here. And if I go into the modifier stack, there's that clone on lerp 2. And what this guy is looking for is 2 points and number of clones. So we'll give it 0.1, we'll give it 0.2, and there we go. Put a third one on there next to it. So we've got, the default was 3, we've got 3 clones there. We can crank up that amount to put more clones, and if I move one of these points around, you'll see that it's going to keep that same amount, and it's just going to change the distance between them. It's going to interpolate how big that distance is and spread them evenly. So one of the really cool things about MCG is, unlike the modifier stack where a modifier kind of is what it is and you can use it and the functionality is set, with MCG you can go back and you can grab somebody else's tool and you can change functionality, add something if there's, it's not quite meeting your specific needs. Somebody had made the suggestion of, with the teapots that are interpolated between the 2 points, why don't you make them all point at one of the points? So we'll just grab their rotation. And the way we could do that is, there's probably a lot of ways you could do that, but the way that would be pretty quick would be to kind of hijack the mesh as it's leaving this implicit parameter modifier tri-mesh and rotate them all before we make the array. So how we could do that is we could drag this input out here, and let's see what we got for rotation. Rotate mesh, that sounds good. And then from there, pipe this tri-mesh back in here. So We now have this in between these two, and we have to figure out how to get what is that rotation, that look at. So let's bring these over here to make some space, and we'll kind of work backwards in figuring out what we can do to get that look at rotation. So we know we need a quat here, so QAT. Quaternion from rotation matrix sounds good. So now we know we need a rotation matrix, so let's work backwards from there. Do our little search feature here, and we'll search look at 3ds Max look at matrix. That sounds promising. Okay, so this is looking for an up vector and a look at. For the look at, we could just pick our point number 2, so it'll just look, all the teapots should look at the second point. And for an up vector, let's just make another node for that. I'll grab all these nodes, and if I hold shift, they all come over together. Once again, make a little space for these guys. We'll plug it in here, and instead of calling point 1, we'll just call that up node. And let's check that out. So we'll do a save as. We'll call that tool clone on lerp rot for a rotation. Save that guy, evaluate it, and let's look at max here. Okay, so back in the viewport, we need a teapot here. I'll move that to 0. We also need some nodes. We need kind of a point 1, a point 2, and this third, what we'll call up node. Move that up a little bit. And then on our teapot, we can place that modifier. It shows up now in the modifier list. We'll pick our up node. We'll call that point 2, and this one point 1. And there we go. Got a bunch of nodes, or a bunch of clones rather, in the viewport. And as you can see, if we rotate this around, they're always pointing at that first node. Thanks for checking out the tutorial. We will post the MCG files, and can't wait to see what you make with it.